Here we have 50 milliliters of HCl at an unknown concentration. Here is Ben pouring the HCl into the beaker. Here is Ben filling up the burette all the way to the 0 marking with NaOH 0.1 molar. This is a pH meter. Ben, show us how to turn it on. There's a button. Ben will now insert the pH tube into the meter. In there. This is that solution thing. Make sure nothing gets in it. Leave it to the side. Make sure it doesn't spill. This is the pH indicator thing itself. You're going to put that into the solution. Ben has inserted the meter into the solution, and we will get our first reading shortly. Ben will be taking 3 drops of phenolphthalein as an indicator for our acid-base titration. Boom, boom, boom. 1, 2, 3. We're ready. Now that the indicator is in the solution, that will be able to tell us when we have reached the end point of the titration. The end point is when the color of the solution has completely changed from white to whatever color the indicator is. In this case, it will turn to pink. I'm now going to add a milliliter of base to the acid solution and stir. It's really tight. This is the final solution. We're now going to plot the pH versus milliliters on a graph.
I hopped off the plane at LAX with a dream, my cardigan.
This point occurs when the pH is around 7. At this point, the moles of H+ originally in the solution are equal to the moles of OH added by the titration. The pH is around 7 because the solution is neither acidic nor basic. The equivalence point occurs because as base is added, the hydroxide ions bond with the H+ in the solution to create water, as demonstrated by the equation Olivia is now writing. We will now identify and explain the half equivalence point. Olivia is writing out an equation present on the AP Chemistry equation sheet that relates pH to pKa. The equation mentions the log of conjugate base over acid. In this case, the acid is HCl, and its conjugate base is the ion Cl-. At this point in the titration, exactly half of the HCl present at the start has bonded with the added NaOH. This leaves the concentrations of Cl- and HCl around the same, so the term log conjugate base over acid reduces to 0. At this point, the solution is a buffer. Olivia is now identifying the buffer zone. During the buffer zone, pH does not change because any acid or base added will bond with the ions present in the solution, resulting in no change to pH.
Here's a tip for the AP exam. You should know 2 words, equivalence point and endpoint. Endpoint is when there are more moles of the base than there are of the acid and the solution has completely changed color. The equivalence point, however, has equal moles of both acid and base. There's a clear distinction between the endpoint and the equivalence point in color and moles.
We will now solve for the concentration of the unknown acid. The initial concentration of the base was 0.1 molar. It required 18 milliliters of this base to reach the equivalence point. Olivia will now write the formula for molarity. Molarity is defined as moles per liter. The initial molarity was 0.1, X is the moles, and it required 18.018 liters to reach the equivalence point, making the mole amount 0.0018 moles of NaOH. At the equivalence point, the moles of the base are equal to the moles of the acid, so we also know that there are 0.0018 moles of HCl at the beginning of the titration. Again, molarity is moles per volume, so we divide by the initial volume of HCl to calculate for our molarity.
Okay, I hope you enjoyed our video about titrations and it's helpful for your days in AP Chemistry.